Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 56 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. It is a very exciting lesson. And what I'm going to do is I am going to teach you how you can build an altimeter using your Arduino and using a BMP180 pressure sensor. So I'm going to go through the math. I'm going to go through the circuit layout, and then I'm going to go through the coding. And by the end of today, you should be able to measure altitude or changes in height using your Arduino. Sound cool? I hope it does. So let's jump in and get started here. Let me get out of your way. I'll have a little sip of my Go juice. And let's jump over. And I should say that last week I showed you how to connect this component up. I showed you how to download the libraries, and I showed you how to make readings from the sensor. Now today I'm going to show you how to take those readings and go out and measure altitude or changes in height. And so I'm going to kind of go through fast a little of this. If I go too fast, go back to last week's lesson, and it'll show you how to get your libraries set up and all of that. But what we are using is, in this particular example, I am using the component in the Sunfounder kit, which is the GY87. And you can see the GY87 up here. Why? Because it has a BMP180 pressure sensor on it. And so if you have the Sunfounder kit, you will have this exact component. If you just happen to have a BMP180 sensor that is not on the GY87 module, things should be the same, because hooking things up are pretty straightforward. You see up here, I have the VCC in pin connected to 5 volts on the Arduino. I have ground to ground. I have SCL to SCL, and I have SDA to SDA. Now, the only thing that I should say is if you have the BMP180 that's not part of this module, you should have these same pins, VCC, ground, and then your SCL and your SDA. So you should probably be able to do things pretty much the same. Now, the one thing I'll say here is that on your actual part, your actual GY87, these stenciled labels are on the other side. And so you have to kind of look on the back to see the labels, or you can just cue everything off of the hole in the upper right, and then you'll know sort of which pin is which. Okay, so that's that. And what I showed you last week is you could go in and you could make a measurement. And what the homework assignment last week was to kind of move around with your sensor and measure barometric pressure. Now we remember that the barometric pressure that the BMP180 reports is in pascals, but if you raised it or lowered it or walked around with it a little bit, you should see changes in barometric pressure as you go up and down even a little bit. And I'm hoping what you found is this thing is really amazingly sensitive, given that it's measuring the weight of the column of air between the top of the sensor and space. And so it's measuring the weight of about 200 miles of air. And with that, it can detect a change of just a couple of feet. And so a couple of feet out of 200 miles is pretty mind-boggling how accurate this thing is. Okay, so what do you know how to do? You know how to take the sensor, you know how to wire it up, and from last week's lesson, you know how to just get the basic measurement off of that. And it's really pretty darn straightforward. But now what we want to do is we want to take that measurement of pressure, of barometric pressure, and we want to do something useful with it. And what useful thing do we want to do with it? Well, we want to calculate a height. Okay, we want to be able to calculate height, because between this height and this height, the pressure changes. And if I do a little bit of physics, a little bit of math, I can look at that change in pressure and I can calculate a change in height. But in order to be able to do that, you will need the barometric formula. Okay. You don't know what that is? Never fear. I'm going to show it to you today. Now, it gets a little hairy and it gets a little ugly, but we just have to be patient and we have to be careful. So what does that basic equation do? It tells you what the anticipated pressure at a given height is going to be. So that's pressure at some height. Okay, and that's going to be equal to the pressure at some base. So we've got to get used to this idea of base and height. Okay, so if I put my pressure sensor on my desktop and measured the pressure, that would be the pressure at the base. And then if I lifted it up here, that would be the pressure at the height. If I was at sea level and measured the pressure and then got in the airplane, and if I was at sea level in my airplane on the ground and I measured pressure, that would be the pressure at the base. And then if I got in the airplane and took off and went way up high, that would be the pressure at the height. But if I'm going to calculate height, it always has to be relative to some base level. So if my pressure base was made at my desktop, then when I come up here, I'm going to calculate 2 feet. If my base pressure was at sea level and I'm sitting here at 6,068 feet, if I enter the base pressure as sea level, then I measure the pressure here, I'm going to calculate 6,068 feet. Okay, so what I'm trying to get you to understand is there's the height of the base, which we're going to call 0, and then there's the height above the base. Now, where the base is where you measure the base pressure. It could be the top of my desk, it could be sea level, or it could be anywhere that you measure it. But it is always a pressure at a base and a pressure at a height. And then the height is going to be the height of the pressure at height over the base. Okay, so here I've got pH as the pressure of the height. How do I get that? I measure it. Then there is the pressure at the base. How do I get that? I measure it. Okay, now we have some different parameters here that I will explain in a minute, but we're going to have the standard temperature and pressure at the base, that's T0 minus L times H, and H is that height above the base. And so what I should say here is pay attention. This is the number that we're going to try to figure out, is this H. That is what we want to know. But we're going to have to do a little math and a little physics. So I have T0 minus L times H, and I will explain these parameters in a minute, over T0. Okay, and then all of that raised to a power, of M times G over R times L. Now, let's talk about what these different parameters are. The T0, what is that? That is the sea level standard temperature. So that is the sea level standard temperature. Now, you might say, I don't know what the sea level standard temperature is. What you have to see is this is in Kelvin, and so Kelvin is a really big number, so slight variations in the actual temperature don't matter. And so you can approximate it as just general room temperature, which in Kelvin, the general room temperature is 288.15 degrees Kelvin. Okay, so we've got T0, and on one day it might be 291, and on another day it might be 286. But given the way this equation works, it works very well if you just use the standard number of 288.15. Okay, now what is the next one? L. L is the temperature lapse rate. Temp lapse rate. And what is the temp lapse rate? It is 0.0065 degrees K per meter. Now, what does that mean? If I'm at sea level and I'm at 288.15 degrees K and I go up by 1 meter, the temperature is going to go down by 0.0065 degrees. So every meter that you go up in height above the Earth, the temperature drops by 0.0065 degrees. So that's why, like, if you're really up high in an airplane, outside the airplane, it's very cold because you've gone through many meters and you had a lot of temperature drops. So we've got T naught, we've got L. Now what do we have? We have H, and H is the height above the base. What is the base? The base could be the top of my desk. The base could be sea level. The base could be wherever you want to measure from. And at the base, you have to measure the pressure. So you have the pressure at the base, you have the pressure at your height, and from those two pressure measurements, you can calculate the height. Does that make sense? I hope it does. And I know I'm kind of repeating myself, but I want you to understand this. Okay, now what is M? Don't be afraid of this. It is the molar mass of air. The molar mass of air. And what is the molar mass of air? It is 0.0298644. I hope you guys are writing these things down because you're going to need this when you start coding. And so the molar mass of air is 0.09. It's 0.028. Man, I didn't even write that down right. Let me do that again. My dyslexia got me. It's 0.0289644. Okay? And I should also say up here, since I'm working in metric units, the height of above the base is going to be in meters. Okay, so that number we get from this calculation is going to be in meters. Now let me see if I can find, give me just a second here. I want to make sure that I'm keeping track of my units very carefully here. Okay, so this molar mass is in kilograms per mole. And mole is like a certain amount of atoms of air. And that certain amount of atoms of air is going to weigh 0.0289 kilograms for each mole. What is a mole? It's like Avogadro's number. It's like there's a certain very large number, Avogadro's number. It's really Avogadro's number, but that number is the number of atoms in a mole. But you don't have to worry about that. You just need to know that this is what it is, and it is in units of kilograms per mole, like that. Has everyone tuned out at this point? Okay, so now the last thing that it looks like that we need is the R. And the R is the universal gas constant. The universal gas constant. And the universal gas constant is 8.31 8.3144598. And that is in joules, J, per mole kilogram, or per mole degree K. Okay, and if you go through all of these things, all these numbers are going to work out. Okay, so now let's see how we're doing. What is it that we want? We want to find H. Okay, we want to find H. But now what are we going to need to have in order to calculate H? Well, I'm going to need, and let's see, let me go ahead back here and remember, P of H is the pressure at height. At the height. How do we get the pressure at the height? We measure it. And then we need the pressure at the base. PB is the pressure at the base. How do we get that? We measure it. Okay, so now let's look at our equation up here. Do I have M? Yes, it's 0.0289, so I have M. Do I have G? Yes, and I should tell you what G is. G is the acceleration of gravity. The acceleration of gravity, and that's 9.8 meters per second squared. 9.8 meters per second squared. Okay, all of these are constants. So do I have M? Yes, I do. Do I have G? Yes, I do. Do I have L, the temperature lag? Yes, I do. Do I have R? Yes, I do. Do I have the temperature, the standard temperature at sea level? Yes, I do. And that's T0 again. And now, do I have L, the temperature lapse rate? Yes, I do. Okay. Now, do I have pH? Yeah, I'm going to measure it. Do I have PB? Yeah, I'm going to measure it. And so now I have, of these, like most of these are all just universal physical constants, and we plug them in. And then there is pH, which I will measure, and PB, which I will measure. I have all of these numbers except H, but that means I will be able to calculate H. I will be able to calculate H. But what do you have to do? We have to do some math here. And what I'm going to show you is really one of the most important math skills that you can have in engineering is variable isolation. Now, I see that I can calculate H, but in the real world, they're not going to just give you an equation. Oh, this is how you calculate H. They will give you something like the barometric formula, and you have to rewrite it in terms of H. So then you can take all of these things that you know, and you can calculate the thing that you want to know, which is the height. Okay, so let's come over here and let's see if we can isolate this variable H. All right, does that sound good? I hope it does. So let me come over here, and I think I will give you a new view here. Okay, so let's go back and let's put that equation in. So I'll start up here. Okay, so I'll start up here, and what did we say? We say that start with a good color here. Okay, so the pressure at a given height is equal to the pressure at the base times the standard temperature, T0, minus the lag temperature times the height over the standard temperature, all raised to the power of mg over RL. mg over RL. So this is raised to the power. The brackets is raised to that power. Okay, now what do I want to solve for? I want to solve for H. I want to solve for H. So what I got to do is I've just got to get everything off of this side of the equation except the H. What is the easiest thing to get rid of first? The PB. How do I do that? I divide both sides of the equation by PB. And then what do I end up with? Well, I'm going to divide the left side by PB. So I'm going to have PH over PB is equal to, now I divided out that PB on that side as well, so it's not there anymore. And then what do I have? I have T0 minus LH over T0. Okay, and then this is all raised to the mg over RL. Okay, now this is the hard thing. What is getting in my way to getting to H? It's that power up there. Okay, it is that power up there. Now, how do I get rid of that power? Well, what I want you to see is kind of like how exponents work. If I have a to the third raised to the 2, if I have a power raised to a power, those powers multiply, and that is a to the 6. So if I have a to the third and I wanted to get rid of it, what would I do? I would raise it to the 1/3, and then that would be equal to a to the 3 times 1/3, which would be a to the 1, which is just a. Now, if I raise this side to the 1/3, I have to raise the other side to the 1/3. So if I want to get rid of mg over RL, okay, I'm raising it to that. What would I want to do? I would want to raise that whole thing. I would want to raise that whole thing to RL over mg. Okay, and then it would be this times this, and that times that are going to make 1, and then I've gotten rid of that exponent. But if I'm going to do that, this thing that I'm raising everything to, I have to do that to the other side of the equation as well. So what are we going to have? We're going to have PH over PB raised to the what? Raised to the RL over mg, because we're going to raise both sides to that. And then what do I end up with? I end up with T0 minus LH over T0, and then raised to the mg over RL, raised to the RL over mg, that becomes 1. And so with that little bit of magic, that exponent goes away. That's what you call a power gamer move there, right? That's a power math move that I just did there. And I just made the whole problem a whole lot simpler. Now we got to get down to H. What's getting in our way now? That T0 that is in the denominator. So let's multiply both sides of the equation by T0. And then I will end up with, on the left, T0, P in pressure at the pH, pressure at the height over pressure at the base. Okay. And then equal to, well, that T0 in the denominator, it multiplies out. So what am I left with? T0 minus LH. Now what's getting in my way? This T0. How do I get rid of it? I subtract it from both sides. Okay. And so now I'm going to have T0 pressure at height over pressure at base, and I forgot this up here, very important, didn't I? RL over mg, and then raised to the RL over mg, okay? And then that is going to be minus T0 is equal to T0 minus T0 goes away, and I just have minus L over H. Okay, now what I'm going to do now is I'm going to divide both sides by minus L. I'm going to divide both sides by minus L. If I divide minus L out on the right, I get H. And then over here, I'm going to have T0, pressure at the height over pressure at the base, raised to the RL over mg minus T0, and all of that over minus L. Okay, now let's multiply the numerator and denominator by -1 to get that awkward L out of the bottom. Okay, and so then what we are going to end up with is T0. Okay, that second T0 becomes positive, so I'll put it first, T0 minus T0, pressure at height over pressure at base, raised to the RL over mg, okay, and all of this over positive L is equal to H. Okay, now what I'm going to do is I'm going to factor out the T0 and the L, because L can come outside of parentheses and T0 and T0 can come outside of parentheses. And now I'm going to rewrite it as H is equal to T0 divided by L times 1, because the T0 over L on the left became 1 minus, and then this T0 over L have come outside the parentheses, and so I just have the pressure at the height over the pressure at the base, and then that raised to the RL over mg, and RL over mg. Okay, is that right? Yes, like that. And now that is the equation to calculate the height. Now let's think about this. Do I have R? Yes, the universal gas constant. L, the temperature lag. M, the molar mass of the air. G, the acceleration of gravity. T0, the standard temperature and pressure. L, again, the lag temperature, the temperature lag. So I have all of those, and I'm then going to measure the pressure at the base. When I start, I'm going to measure the pressure at the base, and then as I move around, I'm going to measure the temperature of the base when I start, and then as I move around, I'm going to measure the temperature at the height, and then what can I do? I can calculate height. Let me make sure that that looks right. Yeah, that really looks right. That looks right. So RL over mg, pH over PB, 1 minus, yeah, I think that this is indeed right. This is indeed right. You need to write this down, and then besides writing that down, what you need to do is you need to make sure that you write all these constants down, because now we're going to have to code it. Now, when we code it, really, it's going to be pretty easy, because all we've got to do is just be very careful when we enter this equation, and then what are we going to do? We're going to calculate height. All right, how cool is that? Let's see how many people are remaining with me at this point. If you're still here, say, I have endured, I have persevered through the math and through the physics. Okay, so now let's jump in and see if we can start coding this thing. So let me come back over here to a code view, and then what I need you to do is I need you to get you a new fresh, Arduino IDE fired up, a bare minimum, and then let's see if we can jump in and start getting this thing coded up. Now, the first little bit is very similar to what we did last week, and so the first thing we got to do is include the library. So I'm going to do a pound include, and then what do I want to include? I want to include Adafruit BMP180, and you can look that up and install it, or you can go back and look at last week's lesson where I show you how to do it very specifically, but you should be able to get that library in there. When you install it, make sure you install the dependencies with it. Now I'm going to create my barometric pressure object, and I will do that by calling the Adafruit _BMP085 library, and now I got to give my pressure sensor a name. I'm going to call it BP. So if I want to interact with the pressure sensor, I interact with BP. So hopefully that makes sense. Now I'm going to need a few Boolean variables. A Boolean is either true or false. So I'm going to make a Boolean variable of BMP connected, and this will be true if it finds the BMP sensor and is making measurements. It'll be true. If it doesn't find it, it will be false. Okay, and then another bool, have base, and that is just going to be, have I measured the base pressure yet? The PB, right? Very important. How many times do you measure PB? One time. You measure that once. Have you measured your base pressure? Yes. True. Have base will be true if you've measured it, or false if you haven't. At this point in the program, I have not measured it, so I will set it to false. Okay, like that. Now, there's a few other things that I'm going to need. If I am going to measure the base pressure, I am going to need to have a variable base pressure. That is where I will hold in pascals the pressure at my base location. Okay, now we can also do a float. What is it that we're trying to calculate? We're trying to calculate the height. What is the height right now? The height is 0. So I'll just put that in just to initialize it with something. That looks pretty good. Okay, now I think we're ready to go in and set things up. Let me just run this and make sure that that I don't get an error. Life is easier if you do a little debugging as you go through. That's looking good. Okay, I think that's going to work. So we're going to come down to our void setup. Okay, it says no device found because I need to actually plug. What matters is that it compiled, but I will go ahead and I'll plug my device in. Okay, so now I'm not going to run it again because I know that it compiled, and that's what's mattered. Now what I'm going to do is I'm going to start my serial monitor, so I will do a serial.begin, and we'll go with the old faithful of 9600, like that. Okay, and that looks good. Make sure that I am not forgetting my semicolons. That looks pretty good. All right, now I need to turn on that BMP. So I'm going to say BMP connected is equal to BP dot begin. So I'm going to turn it on here, and then it's going to return a true if it finds it and connects to it, and it's going to return a false if it can't find it or can't connect to it. So to help us debug, I'm going to say if BMP connected equal true. If it's true, then what do I want to do? Then I want to say serial.println BMP180 found and connected, like that, period, semicolon. Okay, so if we find it, we let the user know that it's found. If BMP connected equal false, that means it didn't find it. It means it didn't find it. In that case, what do I want to do? I want to serial.println. What do I want to print? BMP180 not found. I think that needs an exclamation point. Okay. Check connections. Okay, check connections like that. Put that there like that. So this should see if it finds it or not. Okay. And I think that's what we want to do. I'm going to run it because, right, we've got this thing wired up already. So I just want to see if it finds the sensor. Because sometimes these I2C devices can be a little bit tricky. So let's just make sure that we are finding it and connecting to it. So let's see. I'll run that. Okay, it's downloading. Okay, now let's come here. And now I'm going to press the reset button on the Arduino. BMP found and connected. Man, we're 90% of the way there because most of the work was getting that equation done. Now it's going to be pretty easy to code up, I think. Okay. So now we've got to figure out, how does this thing work? So what I want is, I want the program to prompt the user to put the device at the base level, whatever you want to call the base level, and measure your height from there. Put it at the base level and then say go. And so on my void loop here, I like to do a Control T every once in a while to kind of clean up my formatting. Okay. And so now what I'm going to say, if also, and initially, right, have base was false because we hadn't measured it yet. Initially have base was false because we hadn't measured it yet. So if we haven't measured it, right, if have base equal false, what do I want to do? Okay, if I haven't measured the base pressure yet, I need to measure the base pressure. And in order to do that, I need to tell the user to put the device at the base. So I'll say serial.println place device at base, and then enter go, like that. All right. So I tell them to put it and enter go. Then what do I want to do? I want to give them time to do it. So then I'll say while serial.available equals 0. What do I want to do? Absolutely nothing. So I sit there and wait for them to put in go and then print and then enter. And then what I will do is I will say, I'm not even going to read in the go. It's just whatever they put in the serial monitor and press enter, then I'm going to go with it. So at this point, they have entered something in the serial monitor, meaning that they got their device at the base level. So what am I going to do? I'm going to measure base pressure. And that's going to be equal to BP.read pressure, like that. Simple as that. Simple as that. Now I have read the base pressure. So I'm going to say, do I have the base? Yes. So that's equal to true. Now let me just kind of explain this so you see what we just did. The first time through the loop, we want to measure the base pressure, but only the first time, because the other times we're going to be going up and down. We want to measure what? The pressure at the height. So we only get the base pressure one time. Well, what if you want to do it again? Well, then you just hit the reset button on the Arduino. It will run this program again, and then you can get a new or different base pressure. Does that make sense? I hope it does. Okay, so now we have the what? We have the base pressure. Now, what I want to do is I want to calculate the height, H-E-I-G-H-T. I want to calculate the height, and let's make sure that we put that in up here. Yes, height, okay. Now I'm going to calculate it. And the way I'm going to do it is I am going to create I'm going to create a function to put all that nastiness of that equation and the constants in. So I'm going to say the height is go to the function find height. Now, what is it going to need to know? It's going to need to know the base pressure that we just measured, right? It's going to need to know that base pressure. So I got to pass that down. I got to pass that down to the function. So I'm going to call that, and the number it returns is going to put into height. Okay. Now I'm going to come down here after the void loop. After the void loop, what am I going to do? I am going to put in a function, and that function is going to return a floating point number, and the function is called find height. And then what do I pass it? I pass it the base pressure. Well, I'm going to catch it as the floating point P0. So what am I passing the function? I'm passing base pressure, but I catch that number in P0 because that is going to be easier. That will be easier for me to type than base pressure every time. Okay, so now here is my function. Now, what am I going to need to do? Well, I am going to call the height D. Okay, so I'm going to calculate D, because that's easier to write than height. So I'm going to calculate D. So I've got to define my variable D. That's the height. Now I need to float this T0. That is my standard temperature, right? And what did we say that was? 288.15. And I hope you guys wrote this. I hope you guys wrote it down. I'm going to call mine up again here. I hope you guys wrote it down, but that's 288.15. Then what else did we need? The temperature lag, which was L, and that was equal to 0.0065, like that. Okay, 0.0065. Then what else do I need? I need the R, the universal gas constant. And what did we say that was? That was 8.3144598. Okay, like that. 8.3244. Yep. Okay, that's good. Now, what else do I need? I need the molar mass of the air, and that was 0.0289644. 0.0289644. You guys keeping up? Nice thing is we just got to enter this one time. And then next time you can just copy and paste it from your program. Okay, what we also need is the acceleration of gravity, which is 9.8 meters per second squared. And now what do I need? I need to float the pressure at the, the pressure at altitude. I'll call it pressure at height, pH, like that. I'll do it like we did it, pressure at the height. Okay, pressure at the height, pH, kind of like P0, pH. I'm passing it P0, I measured it above. Now you know what we're going to have to do. What are we going to have to do? We're going to have to measure the pressure at height. And how do we do that? That is equal to BP dot read pressure, like that. I'll tell you, using the sensor is the easy part, right? Doing something useful with the data, that is where the magic happens. Now what I'm going to do is I am going to calculate D, which is our height. And it's going to give it to us in what? In meters. All right. So D is equal to, let's go back and remember your equation that some of you didn't write down. I think you know who you are, right? Guilty as charged if you didn't write this equation down, but now would be a great time to write this equation down. Okay, so now what I'm going to do is I'm going to come over here, and the one thing I'm going to do is I think I'm just going to create a new constant, and that constant, and I'll just call it a float constant. That float constant is that exponential value that we were trying to raise to, right? And what was that exponential value? You know, the exponent that was R times L divided by, open parentheses, M times G. And it's easy to break this equation up into little pieces. And so let's do this where we can look at it very carefully. So we come back over here, and what do we see? What do we see was our exponent that we wanted? Okay, what do we see was our exponent that we wanted? Okay, the exponent that we wanted was R times L over M times G. R times L over M times G. And I've got this in here, R times L over M times G. R is uppercase, L is uppercase, M is uppercase, G is lowercase, so that all looks good. So now my program knows what C is, and that will make coding this a little easier. So the height now was what? It was T0 divided by L, okay, now times what? Times, open parentheses, right? You guys be mindful of your parentheses. And if you do your job good with your parentheses, right, we got a bracket here, and this bracket closes. I didn't close that. Yeah, this bracket closes out here. Okay. That, if you do a good job with your brackets, then the whole thing gets a whole lot easier. So I should have closed that bracket on the outside. So make sure you have that closed bracket in there. But where are we over here? We are at the point where we have T0 divided by L, and then what do we want? We want 1 minus, and then what do we subtract? What we subtract is PH over PB raised to that exponent. Well, how do we do that? We do that with the power function. Power what? Well, it was what? It was PH. I did that differently. PH, the pressure at height, divided by pressure at 0. Okay. Our pressure at height that we just measured divided by P0, which we passed in. So I say take pH divided by P0 and then take that to the power of what? Take that to the power of comma, what? C. Now, isn't that nice that we calculated C so I don't have to put all that stuff in here? This just got a whole lot easier. Now, this closes our power function, and then this closes our overall multiplication. Okay, so this is the big bracket and this is the power bracket, and so I've closed 1, 2. I think that's right. Man, that's going to be interesting to see if that works. Let's just run it to see if that equation works. It's not going to print anything, but let's see if we can get our errors out of here. Before while. What is this before while business? Ah, yeah. Okay. Who's your friend, Mr. Semicolon? What was this? Little t. I find it awkward. Usually in most languages it seems like you uppercase true or false, but not in this case. If have base equal true. Okay. pH was not declared in this scope. What is this? Ah, yeah, I changed the way I was doing it. It's little p, big H, like that. Little p, big H. It's nice to do our debugging little by little, so I think it's going to work this time. Now, the only thing that it's going to do, is it's just going to ask me, right? It's just going to ask me, or it's going to tell me that it's connected, right? Okay, place device at base, enter go. All right, now if I entered go, it would go off and start making the measurements, right? It would go off and start making the measurements. But let's go in and finish the code. So at this point, at least it didn't crash. I've got a height, okay? Now what I got to remember though is the height is reported in meters. If you like meters, more power to you, but I'm a foot man myself, so I am going to say D is equal to D times 3.28084, like that. And I'm converting the D to feet. Right now, what do I need to do? I need to return the value D that I just calculated, and then that's going to take it and it's going to put it here, which is then going to put it into height. Okay, does that make sense? So now, what I think that I want to do is I'm just going to come in now and I'm going to do a serial.println, and then I am going to print height. Could it be that easy? All right, print height like that. Okay, now let's think about this when we run this, and then let's just put a delay in there. What do you think would be a good delay? Let's put in a delay of about 150. So I'm going to put in a delay of about 150 milliseconds like that. Okay. Now, when I do this, when I press go over here, what is going to happen? It is going to read the base pressure. And where is my device? My device is sitting on the top of my desk. Now ignore all that other stuff over there because this is going to be your homework assignment, but all I'm doing right now is I'm just talking to this sensor. Okay, I'm not talking to anything else, so ignore everything else. But now when I press go, it's going to measure the pressure right there. Okay, so now am I actually ready to do this? Am I actually ready to go? Did I print out the height? Yes, I printed out the height. So now let's come over here. And then what I'm going to do is I'm going to put in go, and now I'm going to press enter, and I should be getting a lot of numbers. Now, in a perfect sensor, in a perfect world, it would read 0, 0, 0, 0 because it's sitting at the desk. But what you got to see is I am measuring a column of air that is 200 miles high, and so it's going to have a little uncertainty in the measurement. And I think the uncertainty in the measurement will be like 2 or 3 feet. So if it's sitting still on my desk, it'll read probably between +2 and -2 feet, but it should average to about 0. So let's go ahead and let's say go and see if we get some action here. And we've got absolutely no action. What is that nonsense? Go. Okay, let me try it again here. Okay, so it goes down there. Find height. I didn't get any errors. I didn't see any errors as I was compiling this thing. Do you guys see what the problem is? Okay, let me just try one more thing here. Let me unplug this and plug it back in. Okay. Let me go like that. Okay, so this is not working. Let's see if we actually get down here. So I'm going to put it down here, serial.println, and down here I'll be printing D. Let's just see if we get down here, if we hang up somewhere along the way. It's downloading. Okay, so now let's reset this thing. And now let's say go. Okay, boom. So it's working down here. It's printing down here, serial.println. So it's looping through, it's making a measurement. Now, why is it not doing it up here, serial.line? Okay, now let me take this out. that is peculiar. I'm not sure what is wrong here. Okay, so now we're going to reset it. Found and connected. Press go. So I'm going to say go. Boom, there it's going. Okay, now you see it's not reading a constant 0. It is not reading a constant 0, but it's going between like 1 foot and 2 foot. But let me get this thing and let me raise it up, and you see it's going up to like 2 to 4, 1, 2, 4. And then if I come down and put it on the floor, oops, I kind of disturbed the wires here. So let me see if I can reset it again here. Okay. I jiggle my wires a little bit there. Okay, so let's see if we reset it. Okay, reset everything. Okay, so now I'm going to hit the reset there. Okay, now if I say go, hopefully we'll have some luck. Okay, there it goes. Now I'm going to more carefully put it on the floor. And what do you see? It says it's reading about -3 feet, which is about right. Now if I take it and I put it up here, it's reading about 3 or 4 feet, which is right. So you see, you definitely are seeing a difference between the floor and the ceiling. But let me show you something, I mean, between the floor and me holding it up. Now let me show you something. Come up here to Tools, and then come down and say Serial Plotter. And then what I want you to see is this thing is showing. Now let's see if we can watch it go up. So I put it up here, and you see it went up to like about 4 or 5. And then if I come down here, it goes down to -2 or 3. So do you see that we are definitely seeing something that is amounting to about a 5-foot change in height. Now, what is one of the things that we don't like? All of this noise is kind of causing this thing to auto scale. And so before it was like between +5 and -5, and now it's between 3 and -1.5. So you see, all of this is making it hard. So what I would like is I would like to stop that auto scaling. And the way I can stop the auto scaling is to print 2 values that are larger than the range I'm interested in, and then it will stop that auto scaling. So let me kind of show you what I'm talking about here on the old serial plotter. So what I'm going to do is I'm going to start by doing a serial.print. And what am I going to just print? I'm going to print a 5, okay? And now I'm going to print a serial.print, and I'm going to put a separator for my data. So I will put a comma, okay? And now I'm going to do a serial.print, and then I'm going to print a -5, okay? And now I'm going to do a serial.print, and then I am going to print another comma, another data separator, right? Separation for my data. Who's your friend? Mr. Semicolon. And then I'll print the height. Now it should keep that from auto scaling, and it should just show you 5 to -5. So let's try that. Okay. Okay, so now I will press the reset button. It found it, it's at the base, and I will now say, go daddy, and there, boom. Now watch this. Now if I come up and I look at the serial plotter, okay, do you see what happens now? I pegged it between 5 and -5, so it is not auto-scaling. Now if I come down, you can definitely see that that dropped to something about like -3, -2 to 3. And then if I come up here, you see, you definitely saw it going up, and now it is reading at about 4 or 5. So you see, you can definitely see it coming up and down. Okay, now I ask you, what do you not like? You don't like all of this business. Okay, now what you got to see is the average is pretty good. Do you see how it's coming down to about an average of 0 as I'm here? But all of that nonsense is causing us trouble. And so what I'm going to show you today, I'm sorry this is a longer lesson, but this is really, really important. And I don't think that we have done it yet. Okay, I don't think that we've done it yet. And what I want to do is I want to show you how to make a low pass filter. Okay, I want to show you how to make a low pass filter. All right, so this is what you have to see. Like if I'm just sitting there minding my own business at the top of the table, what do I see? I see that it is going like this. So what does that mean? That means I cannot trust the short-term data. What if I'm sitting at the table and I go up to height? Then it does something like this. It's sitting there at the table, and then as I'm moving up to the height, it does something like that. Okay, so I trust the low frequency data. What is the low frequency data? The low frequency data is like this. What I don't trust is the high frequency data. So what I want to do is I want to filter out the high frequency and I want to pass the low frequency. So what do I want to do? I want to have a low pass filter. Okay. Now, how does that work? I've got to have a new parameter, and that's the instantaneous height. So I'm going to call the instantaneous height now. That is what I just measured, BP.read temperature. That is height now. And that would be this thing that's going up and down and up and down. But now I want a height that I calculate that is the filtered height. And what I want that to be is I don't want to trust all of these incoming data points very much. So I want to trust my moving value, which is height. So I'm going to say, let's trust that to about 95%. So I'm going to say the new height is 0.95 times the height. Okay? Let me fix that. So I'm not going to run off and chase this quickly moving signal. I'm going to say my height is 95% sure it's what my height was before, and I'm going to ignore all of this up and down. But I got to put some value on the up and down, so that's going to be 0.05 or 5% confidence in the height now. Okay, so I'm 95% confident that the height right now is the height that I'm going to keep is the height that it was before. But then I'm going to give 5% weight to this new measurement that I just made. And that way, if you think about it, let's just say for the still case, if it's going up and down like this, and this is the nominal height, when I go from here to here, height is not going to jump all the way up there. It's just going to jump. The error is just going to be a tiny amount, 5%, and then 5%, and then 5%. So you're going to take something that looks like the blue curve and you're going to make it something that looks like this. But then you say, but wait, what happens if you change? Well, if you change and you get something like this, let me do that better. Okay, if you do something like this, and then you go up, and then you come over, well, what's it going to do? It's not going to trust this rapid change, so it's going to stay like this. But then it gets a couple of high values, and that's going to start making it think, well, maybe I ought to come up. Okay, and then it's going to come up like this, and it's going to go like that. Okay, what is this? This is a low pass filter. Okay, now the higher you make this number, and what do I have to say? These two numbers have to add to 1. So it's got to be 100%. So I have 95% confident in my ongoing value and only 5% confidence in the latest reading, okay? Now you could make it 90, 0.9, and 0.1, or 0.99 and 0.01, and you got to kind of dial it in. But the larger this number is, the more stable your signal is going to be and the more noise that you take out, but the more sluggish it is going to be to come up to the value that you want. Okay. Now, the larger you make this number, the snappier it is going to be. It's going to go faster. Okay. It's going to go faster. It's going to go faster. I'm looking for a good color. Okay. It's going to go faster if I make this higher. If I make this higher, it's going to be faster, but there's going to be more noise in it. So if I made this, let's say, if I made this like 15%, then it's going to track it pretty well, but it's not going to take all the noise out. So you're going to have to kind of play with those numbers. But let's see if we can put a low pass filter on this thing, and let's see if we can get this to work better. I hope this isn't getting to be too long of a lesson, but this is important stuff you're learning. If you want to copy and paste code, go to a different lesson, right? I'm trying to get you guys to understand what we're doing. So what does this mean? This means that we need a new variable up here. Now, height is going to be this moving low pass filter applied. So I'm going to need a new variable, float, which is going to be the height now. And I need to go ahead and I need to make the height now. It's going to start at 0 as well. So the height and the height now are both going to start at 0. Okay, now when we come down here, we're still going to measure the base pressure. Okay, now what we're going to do is I am going to measure not height, but I'm going to measure height now. And that is just the reading. Now I'm going to put the low pass filter on it by saying that the height is equal to 0.99 times, let's use 99% height. I really want to get that noise out of there. So I'm going to put 99% trust in the ongoing measurement, height, H-E-I-G-H-T. And then what do I have to make my other number? If one is 99%, the other one has to be 1%. So 0.01 times height now, like that. Okay, now what I want to print this time is instead, I want to still print height because height is the number with the low pass filter. So now let's see what happens here. And I'm going to run that. Let's go ahead and see if we can get our serial monitor up, our serial plotter. Okay, and then I need to come here. I need to, what do I need to do? I need to press the reset button. So it found it. Now I'm going to say go. I'm going to say go. Now I'm getting my readings. So let's get our serial plotter back here. Okay, now boom, you see that green curve? Look at it, and it's right there at 0. So do you see how we got rid of that noise? But now if I bring this up, look what's happening. It's coming up. It's coming up. What do I like about this? I like that I got rid of all the noise. I like that I got rid of all the noise. What do I not like? It is sluggish. So I put it on the floor and it is sluggish. And in fact, it's sluggish to the point that it would be annoying to the user. So what's it taking to get down to the floor? Like 10, 20, 30 seconds to kind of drift down to that floor level. And so I would say that in making the trade-off between getting rid of the noise and having it be snappy, I would say that we got rid of the noise, but it's not snappy. So let's come in here. Well, like instead of 99%, let's trust the existing value 90%, and let's trust the new measurement 10%. So this is going to be snappier, right? This is going to be snappier. So now let's run this thing. Man, I've almost finished my whole coffee here. All right, all right. Let's look. Okay, let's hit the reset button. Let's say go. Let's call up our serial plotter. I think I can just hit that. There it is. Okay, now watch this. Boom, you see that is a lot snappier, okay? That is a lot snappier at the 90. Okay, that is a lot snappier at the 90. So you see I can come up, I can come down, I can come up. But you know what I think? I think now I want to run this thing faster. So this delay of 150, let's see if we make that, let's say if we make that 50. Okay, let's make it 50 like that. I want this thing. Now it wasn't real snappy because I had that delay in there. So I think now we actually gotta lower that delay. And then we're gonna reset. We're gonna say go. We're gonna come up with our serial monitor. And that darn thing went to the wrong value. So here it is. So I go up and it goes up. I go down and it goes down, and I go up and I go down and I go up and I go down. And then if I come back to the table, it's coming back to, it looks like about 1 foot, 0 to 1 foot. So you see there's a 1 or 2 foot uncertainty in this thing. And then I'm going to go back up, and then I'm going to go down to the floor. And I would say that that is pretty darn good. I think that is pretty darn good. I'm going to try one other one. Let's see if we can split the difference. I'm going to take this down to, I'm going to take this all the way down to 10 milliseconds. And then I'm going to have like kind of in between 95% confident in the ongoing value and 5.05 on the new value. And then let's see how that works. Now this is going to be going a lot faster this time because we dropped that delay time. Okay, so we are going to come in, reset. We are going to say go. And then I am going to call up the serial monitor down here, the serial plotter. That is not the serial plotter. Where did that serial plotter go? I guess I got to call it up from here again. Okay, now look at that. That's really hovering around 0. I go up and look at that. It goes up. It goes down quickly. I like this 95%. It's like it's got most of the, it has most of the, it has most of the noise out of there. But let me just show you what that low pass filter is doing for you. So what I'm going to do is I'm going to go ahead and I'm going to serial.print, and let's see. I'm going to do one more. I'll do it above this. So I'm going to do a serial.print, and I want to print the height now, which is the IGHT height. Now that's the unfiltered value. Okay. And then I need to put my comma in, serial.print, put my comma in like that, and got my semicolon. So now let's look at the filtered data versus the unfiltered data. Hit the reset. Come over here. Come over here. Oh, I didn't hit go. Okay, sorry. Scared me there for a second. Let's hit this. Go. Okay, now we'll come back to the serial plotter. Bring it over here. Okay, look at that. Do you see that green is the unfiltered and the orange is the filtered? So you can see the orange takes a little while to catch up with the green, but isn't it nice to get rid of all that noise? Can't you interpret this data a little bit more accurately, a little bit more intuitively? You can also then like turn that off, or you can turn the filtered what is it, the value 4 there. You see you can turn the filtered off, or you can turn the unfiltered off. I wonder if you take these out, then yeah, you lose your auto scaling. So you want to leave those on. But all right, guys. Now tell me, this was a long lesson. And you tell me if you would rather me make this channel where I show you how to wire it up and then I give you code that you copy and paste and then you can make this thing work. Or do you really want to understand what's going on by going in the math, the physics, and now what did we learn today? The low pass filter. And these low pass filters are really, really incredibly useful in almost anything that you are going to want to do. Now, at this point, this is really cool, but what is the biggest problem? Now, I'm going to give you a homework assignment now, okay? I'm going to give you a homework assignment now. But what is the problem? We are pretty accurately measuring height. We're measuring height, and right, we're basing it. We got a 200-mile column of air above us, and we're able to measure a difference of 1 or 2 feet. And that is pretty amazing, pretty incredible. But what is the thing that we don't like? The thing that we don't like is this darn cable. Okay, this darn cable, because we are tethered to the computer and we can't go out and see just exactly what this little gizmo, which I am calling now the height-o-matic, exactly what this height-o-matic can do. So what do you want to do for your homework assignment? You want to untether. You want to untether from the computer. Okay, you want to untether from the computer and you want to power it from your little power module, your breadboard power module in your Sunfounder kit. And then the way I have this thing working is I don't have the program loaded in it, but what you do is you're going to put a prompt here. You're going to put a prompt here on the screen that says, place the height-o-matic at your base location and then press the go button. Then when you press the go button, it's going to start making measurements of height and it's going to display it here on the screen. And then you can walk around mobile. You can walk around untethered and you can say like, okay, start downstairs, go upstairs if you've got stairs. If you're near a building with an elevator, start at the bottom of the elevator and then go up to the top of the building, okay, and see what you're measuring for height. If you got an airplane, take it up in the airplane and see how it is working. Or if you're just more limited, height variations, put it on the floor and then stand up on a chair and hold it above your head. But play around with this. And then what I want you guys to do is I want you to make a video of this thing in action and show us what you're measuring. Show us where you're going, what you're doing. Maybe it's just sitting here like me going up and down, or maybe you go to an elevator or whatever, but make a video of this thing. So that is your homework assignment for next week, which is actually to kind of make a portable altimeter based on the Arduino. I hope you guys are having as much fun taking this class as I am making it. At this point, as always, I want to give a shout out to you guys who are helping me out over at Patreon. Have had some new support come in the last few weeks. Really appreciate it because it is you Patreons that keep this great content coming week after week. I am able to post 2 fresh, new, quality educational videos every week because of the help that I'm getting from my Patreons. Thank you. You can also help me by giving me a thumbs up on this video. As you do, also leave a comment down below because that will help me with the old YouTube juice. If you haven't already, subscribe to the channel. When you do, make sure you ring that bell so you'll get notifications when future lessons drop. And most importantly, share this video with other people because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later. Let's see. We've got some fishermen out there. Let's check out the front yard. Okay, maize is coming out very well. You can see the maize crop is coming along very far out there. You can see Freddie is getting some weeding done. So that's the front yard. That's Riverview 1 and Riverview 2. Hey, got another fisherman up there off in the distance. Okay, guys, I will talk to you guys next week. Paul McWhorter signing